Hello everyone. In this problem given is an equilateral triangle. We choose an arbitrary point inside this triangle. If we draw three line segments to each side such that these line segments are perpendicular. First we draw this line segment which is perpendicular to this side, another line segment, this is perpendicular to this line segment, and this line segment is perpendicular to this side. If these line segments have length 4, 6 and 8, then we have to find the area of this equilateral triangle. Let we move towards the solution. First of all, we describe the Viviani's theorem. We will use this theorem to prove to find the area of this triangle. Viviani's theorem states that in an equilateral triangle, the sum of perpendicular distances from an arbitrary point to the sides is always constant and is equal to the height of triangle. Let we describe it geometrically. If we have an equilateral triangle, we choose any arbitrary point inside it and we draw three line segments which are perpendicular to each side. If these sides have length ABC, then the height of this triangle must be equal to A plus B plus C. This is what the Viviani's theorem is. We will use this theorem to prove to find the area of this triangle, but first we prove the Viviani's theorem. Proof of the Viviani's theorem: we can divide this whole triangle into three triangles, such as, first we label the points, and since this is equilateral triangle, so we call each side as S. First we draw this triangle. Here the area of this triangle is half time base, which is S, and height is A. So area of triangle OBC is equal to A times S by 2. If we draw this triangle, that is OAB, area of this triangle is equal to half time BS, and this triangle OAC triangle, its area is CS divided by 2. And if we consider this whole area, which is ABC, then this is equal to half time HS. So since this area of ABC is equal to the sum of these three areas, we substitute each value. HS by 2 is equal to AS by 2 plus BS by 2 plus CS by 2. Taking S by 2 common from right, we have this one, and from here 2 and S will be cancelled out, and thus we have H is equal to A plus B plus C, which is the proof of Viviani's theorem. Now we will utilize this theorem to find the area of this triangle ABC. Since the problem given is with length 4, 6 and 8, so height of this triangle must be sum of these according to Viviani's theorem, which is 4 plus 6 plus 8, that is 18. Now we consider this right triangle, and its height is 18, hypotenuse is S, and this length is S by 2. So using Pythagorean theorem on this, S square will be S by 2 square plus 18 square. S square will be S square minus S square over 4 is 324, and from here we have 3 by 4 s square is equal to 324, and from here s square is 324 multiplied by 4 over 3, which is equal to 432, and if we taking square root on both sides, s will be equal to 12 times square root of 3. Now we have base and height, so s is this length, which is 12 square root of 3, and height is 18. So area of a triangle is equal to half time base into height. So base is 12 under root 3 and height is 18. Substituting and simplifying, we will get area of triangle is equal to 108 times square root of 3 square units. That is the answer. Thank you for watching.